Oh, excellent. Okay, so it looks like we'll just start right now. Why not? Um, when is he in the back? So we have our public service announcements. I think instead of waiting 15 minutes, we'll just start the debate 5 minutes after. I think that's when the alcohol and beer will be in, so everyone will be happy or so. Okay. Okay. So enough of that. So thank you all so much. I'm Solomon Sonia. And it's a pleasure, it's an honor, it's a blessing to be here in front of everyone. I'm here, so I've had a good time working on Splinter, and hopefully we'll be able to learn something as we progress through these slides together. So first, I'd like to start off with the obligatory disclaimer, just saying that use the knowledge, I guess, that we discuss, or use knowledge in hacking and things for good. Use it for good and not for evil. So all of that text is just saying, as hackers, please be nice, because if you destroy somebody's computer system, although I built the tool, I'm not responsible because one of you actually executed on another computer system. So please just be safe. Be safe and be kind. Is that fair? Fair? Okay. All right. I'll take that as a yes. So this is what to expect in the following presentation. For the most part, I think it'll be obvious what we cover just as we go from slide to slide. But one important thing is this bastard, our live demonstration gremlin. So in America, whenever we say like a curse word, we say, excuse our French. So if we're in France, what do we say? Excuse my American? Will that work? I don't know. I'm not sure. But just in case any of the live demonstrations fail, I'm sorry. It just happens. For whatever reason, you get up here, you try and do a demo, and things fail. But hopefully it doesn't. And if so, I have a backup laptop. Hopefully everything will go well from there. So the research motivation. As we know, pretty much as everybody has alluded to in the presentation that we spoke about today, is that network security is still falling behind to stay ahead of emerging threats. So therefore, in order to be able to be stronger with our network security and our network defense, pretty much if you want to be really good at securing your enterprise network, you kind of need to know exactly the in and outs of exploiting this computer network. So that's why I developed this botnet. So if you understand how to use a botnet, if you understand how to exploit your networks with botnets, then perhaps you have knowledge of what to better look for in order to secure your systems in case you see activity that's malicious or activity that's indicative of botnet infection. So as I talk about botnets, what exactly is this botnet that I speak of? Well, this is our terminology that we'll use for today. All of this information is from the Book of Solomon, i.e. me. So a botnet. It's pretty much it's a network of autonomous systems, agents that are synchronized with a command and control server in which we exchange information, we exchange commands, and then we also handle our remote exploitation of those end systems. When I speak about the controller is us. We are the controller, we are the botnet masters, we are the person who use one user interface to send commands to all of our distributed systems across the network or across the enterprise. The dropper, we have a slide on the dropper. It's pretty much just saying that's going to be one way of having an entry point into that infected machine. And finally, the implant. The implant is the listener that actually establishes his connection to the controller, executes whatever commands that we receive, and then sends that information right back to the controller. So now we have our botnet communication. And then we have other notes at the bottom. We want it to be as lightweight as possible so we can establish a shell to the controller. Whenever the controller sends information on my listener side, I simply instantiate a new process. I execute the command that was just received. Then I open 3 streams on that process in order to execute commands. You open your standard out, a standard error, and then also a print writer so I can correspond with that process. Any information that I get across the standard out or the standard error on each process, I simply buffer that information and I send it back to the controller. And this is pretty much how you establish your botnet. So I'm a visual learner. I'm also a teacher, so I kind of like to have diagrams. Hopefully this helps, because I say a lot of words, I wave my hands, but if you look at the pictures, we'll say, ooh, ah, and then we'll understand what we're talking about. So here we go. Right here, we are the botnet master, we are the controller. If you understand using your algorithms to send commands to one of the infected machines, receive the response from the infected machine and send it back to the controller, if you understand how to program that for one instance, and then if you can use the same function to execute the commands for the next instance and the next instance after that, then actually by induction it means you understand how to create and how to control your botnet. Okay, very nice, very nice. So where exactly do we begin if we're talking about establishing our botnet, controlling information, and controlling these end systems? Well, let's go ahead and look at our anatomy of an attack. Most people are very familiar with this. You start out with your reconnaissance, then you do your scanning to understand my entry points, and the vulnerabilities into that computer network, and then we try and penetrate that system. This is also referred to as gaining access onto one of the infected machines or one of the vulnerable machines that we wish to have access to. Now, after you gain access, after you penetrate that machine, and you stop your happy dance, because hacking is not as easy as some people like to make it appear. So once we stop dancing, because we just got a shell onto that computer machine, now we have options. Are we going to escalate privileges? Perhaps we're going to pillage and plunder, as Mr. Darrell and Mr. Pete alluded to earlier, whenever we have access to those printers or any of those infected machines that we're talking about. Or do we pivot? Do we actually try and propagate our malware? Because from my computer system, I now, whenever I penetrate a network, I now have access to more systems inside a separate network. So do I continue to scan and then try and infect more machines that way? Or perhaps I'm going to just paralyze every single system out there. It all depends on the goal of your attack. And then after that, we actually move down to stealth and persistence and covering tracks. Other diagrams like to have persistence and then covering your tracks one on top of the other, or covering tracks and then persistence. I put them side by side because it's actually an iterative loop in which, as I continue the attack, I like to try and be as stealthy as possible, or I'd like to maintain access. So it's something that we go back and forth. It's not just you do one and then you move on. So good. Now that we understand our anatomy of the attack, let's focus on penetration. So earlier, I alluded to the dropper. I really like the dropper implant paradigm whenever I'm infecting a computer network. So let's see. Ooh, another pictogram. So here we are the controller. The controller, we have access to a malicious domain that we use in order to serve additional malware to infect computer machines. So with a dropper, as soon as we have a dropper is supposed to be as small as possible. And the only purpose of that dropper is simply to break into that victim machine and establish the environment. There are many different types of droppers that can exist. I can use an exploit. I can use a malicious PDF. We'll be using Social Engineering Toolkit created by Hacking Dave Relic. I'll talk about that more in the slides to come, in which we are actually going to try and steal credentials to gain access to a network. Let's see, what else do we have? Okay, so whenever I have my exploit, my dropper gets into the infected machine, the dropper then reaches out to my malicious domain, and it actually pulls down the implant. That implant is what is established onto the infected machine now, and then it establishes his connection up to the controller. And from that moment on, the dropper goes away, and now I have my two-way command and control between the implant and the victim machine. So now the implant is connected to my controller, as we spoke about earlier. Stealth and persistence. This is what we call our beacon bot. And the inspiration of this was actually from Raphael Mudge. Do we know Raphael Mudge? He's the creator of Armitage. Okay. Raise your hands if we used Armitage before, or at least we've heard about Armitage. Oh, good, excellent. So there's a pretty good show of hands. So we're going to use Armitage. It's a wonderful framework, very, very nice. Or you can use Metasploit to actually handle additional exploitation of that computer machine. But at a presentation that myself and Darrell, %X, we were at Hacker Halted last year, and Armitage, Raphael Mudge, he was talking about sometimes whenever you have access to a network, you don't just want to have a long established socket connection between your controller and then the implant, because this in and of itself can be indicative that, hey, why do I have one of my machines having a connection that lasted for 25 hours to another system? Why do you need a connection established for so long? So instead, he spoke about creating a beacon bot. And you can use a beacon bot to establish persistence, maintain access to a computer network, but without having a persistent socket connection to your controller. So what does a beacon bot look like? Haha. So we have another pictogram. Here we are the controller on this side, and then we have our victim box. As soon as we establish our beacon on the victim box, the beacon will wake up, and then he will actually send a packet to the controller. He will send a packet to the controller to register himself, saying, I am live, I am active on this infected machine. The controller acknowledges that beacon request, and then the beacon goes to sleep. It severs that socket connection. So whenever a specified period of time elapses, the beacon bot then wakes up and contacts the controller. Do you have command for me to execute? The controller says no. So what happens? The beacon goes back to sleep. Then the beacon wakes up. Do you have commands for me to execute? He says no. Okay, he goes back to sleep again. He wakes up one more time. Do you have commands for me to execute? You say yes. Okay, no problem. So what exactly do you want me to execute? So now we're checking in, we're downloading the command list. In this case, the controller says, establish a shell back to me. In this instance, the beacon woke up, he took the command, he says, you want a shell? Okay, I will give you a shell and establish this back to the computer system. So we are going to actually do some interactive demos. So let's go ahead and look at the beacon bot real quick, and so we can see what we're actually talking about. Okay, so here we are. This is Splinter. This is our botnet controller that we created. It's available on GitHub and also on Twitter. I usually tweet about the access or how to get it. So if you want to establish your controller, the first thing you do, you establish your server socket, which allows you to receive new connections onto the controller itself. And then also an FTP socket. This allows me to exchange files and things like that. So pretty much after that, everything else is supposed to be as simple as possible. And I'll show you things as we progress throughout this demonstration. Okay, so let's establish a beacon so you can see what it looks like. Let me use, oh good, okay, yeah, this is it. Okay, let's go ahead and clear this. CLS? Aha. Okay, so if I do want to establish the beacon, the parameters for the beacon, you pretty much just say splinter.exe. And if you do -H, I have a help option that I show you all of the options that you can use for this actual implant. So here we are going to use the beacon option. So if we enter in Splinter -B for the beacon, and then the IP address to the controller. The IP address of the controllers in this case is 192.168.223.1. Yes, it's right here. And then the port that we're listening for server socket connections is across port 8080, which is right here, established port. So I do a space, 8080, and then the next parameter will be my beacon interval. How often do I want the beacon to sleep before checking in with Mr. Controller to see if are there commands for us to execute? I will tell it 6 seconds for now, and then I'll press enter. Okay, that's my firewall that's on. Let's go ahead and turn that guy off. He'll kind of mess up my demonstrations here. Don't do that. Okay. All right. So it looks like our beacon is connecting over to us. So at this spot, if we click on the beaconing agent command terminal, this tab, you can actually see whenever a beacon checks in, he checks. Okay, beacon check-in has just been received, and that's the beacon's ID. And at this spot, we don't have any commands loaded for him to execute. So if you do want it to execute commands upon the next check-in, let me do this. Okay, you can come over here to the right and then say add command. So 2 commands, let's do who am I? If I can type right, who am I? Okay, and then also, let's do WMICOS get caption. Okay, so you can actually queue up multiple commands whenever an implant actually checks in. And then to enable it, you just click enable to the right. It turns green on this side. So the next time the agent checks in, he downloads the commands list and then provides you the response. So here I see that I'm executing on a Windows 7 professional machine. And then also who am I? I'm listed right now as an admin PC. Okay, now let's go back to the connection status. And if you click on the active tab, you see that we have no active connections into the controller. So the main purpose of the beacon, right, was to say, okay, when is it time to establish a shell to us? So I just disabled all of the beacon commands, so the next time the beacon checks in, it just says, okay, check in, 0 commands established. Okay, so if you click on shortcut, I'm going to say establish a shell. And upon the next time that the beacon checks in, I'm waiting for him to check in. Okay, good, so he just checked in. So the next few seconds, we should now see the beacon is going to return a shell to us. Okay, and so that's the shell that the beacon just responded to us. And actually, do I have internet? Oh, okay, so I actually built in a resolution in which I can do geolocation for the implant that checks in, which I was thinking it's sometimes nice whenever you have many sockets, you don't know where these computers are. So I actually display a map to show you, well, this is the greatest or latest resolution of where that infected machine actually is. So if you want to see that, you click on the beacon or you click on the connection here, and then you move over to Google Map. And then Google Map will actually display on your, using your default browser, where I believe that connection is coming from. I'm connected to the internet. Sorry, I wish that one would work. It might work in the next one. But let's see. We'll just continue. We'll continue. So at least that was an example, just a very quick example of using the beacon bot to communicate with our controller, check in, receive commands, and then go to sleep again. Okay, so penetration, payload migration. Whenever you build your botnet, or whenever you build a tool that has command and control and sockets established, I think one thing that is very important is to make your tool extensible. Or liken it to this. 2 months ago, or so, we released an update to Splinter, put it on GitHub. What if at that spot we had a beacon that was established on an infected machine? But no kidding, 2 days ago, or whenever we flew over from the United States over here, I created a new payload and I put it into the system. So how do I now get that update to affect the beaconing agents that I've had running for the last 2 months? Will that guy see the new update that I just created today? No, he won't. So in order to have this feature, like an update feature or an extensible feature, I created the payload migration. A payload migration allows you to take any binary or pretty much any file, migrate it over to the infected machine from the same socket, execute it, and now I can continue additional exploitation onto that infected machine. So let's say, let's say if I have an initial connection to that infected machine, and now I want to run clear logs, or I want to run any other exploit. Sometimes, whenever you magically find yourself on an infected machine, and then you say, okay, but I want Armitage on that infected machine, not Splinter. Well, I allow you to transfer over pretty much any payload that you have now to that same infected machine using what we have. So here's a diagram of what we're starting with. So we're going to start at the controller. We already have an established connection to the infected machine. And now we have Metasploit. We also want Metasploit to have access to the infected machine too. So what happens many times, if I have Metasploit, I say, okay, Hail Mary, or do whatever you can to give me access to that computer machine. Sometimes it works, sometimes it fails. But let's say one of our droppers was successful to give you access to that computer machine. Let us now find a way to get Metasploit onto that infected machine also. So this is what it looks like. What we will do from Metasploit, we will create a reverse interpreter, and then we will transmit that reverse interpreter from the control socket onto that infected machine. Then we'll execute it on the infected machine, and now we will bring a socket over to Armitage, or over to Metasploit, if that makes sense. I hope it does. If not, don't worry. We have another demonstration. Okay, let's do this. Okay, so here's Armitage. We have it running, and then we have our listener established right here. Listener, this is the IP address of the Linux machine, and then this is the port that we're listening on. Because of time, I've already created the interpreter, reverse TCP, but if you have any questions on that, I have a how-to from the GitHub link that will show at the end. So if you want to see how did I create that, I mean, it's pretty cool. Or you just Google interpreter reverse TCP, and everybody and their brother likes to write about how to use Metasploit. Okay, so let's go ahead and migrate the payload. What we want to do now, let's use the I feature from the implant. So this is going to be our infected machine for today. Let's go ahead and clear that also, because I just want to make sure it worked earlier. Let's make this larger. Okay, so if I enter in Splinter, okay, -I now, because I'm just establishing an implant connection out to my controller. And then the IP address is 192.168.223 in this case. One port is 8080. And then I have, this is optional, an optional field at the end. This says, okay, in case the current socket is dropped, how soon do you want me to wait before I beacon to establish a connection back to the controller? If you put T5, that says connect immediately. So I just want to make sure that I have a persistent connection. Okay, so it looks like that was successful. And now I have two machines. It appears to be Windows Vista. This is because I need to go back and fix that resolution. But we have Windows 7, which is the host, and then what appears to be Windows Vista, but it's really a Windows 7 machine that we've just infected. So this guy. Now, the main purpose here was to migrate payload. So if you click right here on migrate payload, we can now specify any payload that we want to transfer over to the infected machine, execute it, and then bring that shell over to a different tool, which we're now going to connect to Armitage. So at this spot, there's no connections into Armitage, unless, let's hope this works. Okay, so let's move this guy over there and here. So I specify the payload that I want to transfer over, and the one that we'll be transferring is this guy, just a reverse TCP over to Armitage from our Splinter connection. I'll say open, and then I also allow you to prepend and then append any additional parameters. So if it's a separate tool that has its own parameters to execute, sometimes you say, well, how do I extend parameters? I give you that option at this spot. And I think if you hover your mouse, I put a tooltip in there that says, okay, good. Yeah, so it kind of gives you hints, sort of. And if you're not sure, just leave it blank and see what happens. Okay, then I click check options just to see where I'm going to put it. I'm going to put it in the infected machine's temporary file, temp folder. And then at the bottom here, you have an option. Do you want me to execute the payload immediately upon transmission to the infected machine? Or do you just want it to stay there and then I can execute it at another time? So you just say yes or no. And so we'll hit launch. And if this launch is successful, don't be so fast. Okay, let's see if we can get the connection into Armitage. If it works, okay. Okay, good. So what you just saw was a separate Armitage connection, or it's just any other program that I can now exchange from my current botnet to allow other people to have access to an infected machine as well. So that's just our payload migration feature. And it doesn't have to be Armitage. It can be any executable or any file that infects the machine. I just thought, whenever we establish a botnet, it's good to allow additional tools to migrate from that infected machine. Okay, what's next? Social engineering. Okay, this is a favorite. It's a fave of mine. So if we can recall from yesterday, Mr. Wynn spoke about the four-letter word that's the worst, insecure into the computer network, right? That was supposed to be the user. All right, very good. And he also spoke about, what was it, the corona, the sun flares, solar flares. Okay, so at least we have two really good things. The users are bad and solar flares are just bad panda to everybody. Okay, so what we're going to talk about now is DNS host file poisoning and then credential harvesting. And spoof UAC, I don't think I have time for that, but if we have time at the end, just remind me and we can show the spoofing of the user accounts control also on Windows machine. So DNS cache poisoning. The main purpose of establishing a DNS cache poisoning is, let us say, Mr. Controller over here, he is the legitimate DNS server, okay, or he's a legitimate website, and let's now say you, sir, are now the attacker's malicious website. I am now the attacker, I'm the man in the middle. You now want to go to the legitimate website. Let's say you are Amazon or bankofamerica.com, okay? So you want to log into your bank to check your account. I now, if I can poison that DNS entry, I can say, no, don't go to him who's a clone of this actual website. So you not knowing the difference because they look exactly alike, you go to the malicious website, you enter in your credentials, I now steal your credentials, and then I forward you over to the real website. So you don't really know the difference that, hey, I just have your credentials. Okay, that's pretty much one of the main reasons that we do DNS cache poisoning. So back in 2007, 2008, we saw that, wow, some really bad DNS cache poisoning was going on. And then what did we do? We actually patched it. So if I did want to poison a lot of our main top-level domains, I believe that was the one that the attack worked in 2007, 2008. In order to do that, I would have to be very noisy because I would have to constantly poison almost every single DNS top-level domain and also the authoritative domain servers across the entire world and say, no, don't go to Bank of America here, it's actually here. Again, that's very noisy and it's been patched. At least most of it's been patched by now. So we're not going to do that because it's noisy and it just won't work well. The next thing we can do is a man in the middle, which I kind of explained. If I am inside the network, instead of you going to bankofamerica.com, I now cache poison both of you. I say, okay, you are now the router, you are now the legitimate website. I am the attacker. You do not go to the router, go to me. Any packet that you send, I'm going to forward to the router. I'm now going to tell router, do not send anything to him, send it to me. So now back and forth, I can continue to control every website that you go to. This, again, is very noisy because I have to continuously send gratuitous ARP packets in order to continue that man-in-the-middle attack. And it's also very detectable if you're monitoring the packets on your network. So we're not going to do that either. Instead, let us actually manipulate just one entry. We'll add one entry to the infected machine. And then by adding an entry to the infected machine, we're going to target the Windows host file. So actually say, okay, instead of going to your main domain server and then handling all of our DNS requests, only go to one file. If you see an entry in the file, go to that location directly. So if that works, a lot of people say, wait a minute, what is the host DNS file? Okay, good. I'm glad you asked. So the host DNS file. This is a location where the host DNS file actually exists. It's pretty much an important file that can be used to handle registries and locations very quickly. I'm going to go to the next slide because we're running out of time. So this is how it works. Let us say you want to go to facebook.com. My computer system, assuming everything is going to work well, will check its host file first if an entry exists. If an entry exists, I'm going to pull that IP address. I'm then going to send it back to my browser and say, okay, you want to go to facebook.com, here's the location of Facebook that you were looking for. So go there instead. This now means that we've just found an exploitation vector. If I can poison that host file, I can now direct you to anywhere you want to go based off of the initial website that you're trying to go to. So, and now for the attack. More pictograms, yes? Okay, so here we are. We are the controller. We have access to the infected machine. all we're going to do is send one entry to the infected machine saying this is the location and this is the IP address of any site that the user might have wanted to go to. Then we're going to use the social engineering toolkit. Very beautiful. It's a warm fuzzy. The social engineering toolkit works very well. One of the things that we're going to use it for in this demonstration is to actually clone a website, and then if I can steal the user's credentials, I'm going to forward it back to the attacker, and then I will redirect the user back to the legitimate website that they wanted to go to. Okay, so let's see. So it's demo time. Let's see if this is going to work well. Hopefully this works well. This is kind of like the hardest one, I think. So let's go back into Splinter. Yes, so this is the machine that we have. So if you first off want to look at the registry file or the host DNS file, click on your shortcuts, go down to grab host file. Okay, right there. Grab Windows host file. Okay, so if you successfully grab the file, it says this is where I saved the location. I gave you a shortcut right here. If you click on Open File Hive, this is the infected machine that we had, and then this is the host file that we just grabbed from the system. So it's just a flat file, no text file. If I look at it, these are the current entries on that infected machine's host file. So there's nothing in there. So that means if I wanted to go to facebook.com, there's no entry in the host file. I would then contact my local DNS server that handles all of the DNS requests. Okay, so let's go ahead and put an entry into that host file. So if you want to do that, click on the shortcuts and then say append to Windows host file. So what I'm using the social engineering toolkit on the Linux machine is to mimic a website that we've all seen many, many, many times. And it's this website, Hack in Paris. Okay, so the IP address that I'm mimicking on this side is going to be 192.168.223.143. So if I go to this website right now on my computer, you might even be able to do it too if anyone is trying, because I'm connected to the internet, it looks like. So you might actually be able to see this site too. So on the plane, no, right before I got on the plane, I went to our Hack in Paris website and I saw, oh, look, there's a user login and a password. Let us clone this site and see if we can use this for social engineering toolkit. Okay, so what we're going to do now, we're going to tell that infected machine, the host, the entry for www.hackinparis is actually located at this address. And if this works, the user will go there, enter their credentials, and I can check on the social engineering toolkit if it harvested the credentials. So let's see if that's going to work. Hopefully this works. Okay, so what we did, we clicked on append to Windows host file on this side. And then we enter in the IP address that we want to clone. So right now it's hosted at 192.168.223.143, right, I believe? And then the URL that we're actually trying to redirect the user to is www.hackinparis.com. Oh, I hope I'm not talking too fast. If I am, just raise your hand and I'll slow down, because there's a lot to do and I want to show it all. Okay, so just a note saying that it needs to be run with administrative privileges. Okay, so right now, the implant actually echoed back saying he just appended to the host file and we did not report any errors on the host file. So now we just sit back and wait. And let us assume that this is the user now on their machine. So you have this up, you have the output, but it's intentional. I have an implant that does not show any output on its side. Okay, so if I were to go to www.hackinparis.com, okay, I hit enter, and hopefully it does not look like anything. Hold on. Yeah, the user right now cannot tell that anything is wrong. This looks like the correct website. I'm trying to go over. Oh, let me just do this. Okay, so hopefully you can see there it is. Okay, so now it looks like, okay, well, let me go ahead and log into hackinparis.com, right? So assuming I had a username, let me just say user1, and then a password. What's the password? Say a password real quick. Oh, I love that one. Fluffy bunny, right? Bunny? Fluffy bunnies? Okay. So let's say enter. Do you want to remember passwords? Why not? Okay, and So I think if my internet was working right, this now would have been the redirect from the credential harvester redirecting you back to the legitimate website to try and log in. So the user might see that, oh, why did I have this redirect? If they even paid attention. If not, you just enter hackinparis.com and you try and log in again. Because you might just say, oh, well, it looks like the login failed. But let us now go to our credential harvester, which is running. Let me go to the location. Any file that we do receive from the harvester will be saved in var, let's be quick, var www directory, and then we should have a file. It looks like it did not save. I should have run this again. If this did work, you would have seen that there was a text file saved at this location. If you would have opened the text file, you would have seen that the user's name and their password would have been saved into that file. It looks like the live demonstration gremlin got me there. I'm not sure why. I could try it on this one, but that's okay. We'll continue. Just try it on your own side. Everything else worked, though. We poisoned the DNS. Whenever the user wanted to go to that legitimate website, it redirected them over to the credential harvester. The file should have been there. I'm not sure why it's not there. It worked in the back. Trust me. Okay. Just trust me. Just trust me. Just trust me. Okay. So besides that one, let's do just one more. So scorched earth. Scorched earth is kind of a term that's used, okay, if I cannot gain access to a system, or if I cannot have something I want, nobody will be able to access this computer system, right? Scorched earth, I'm burning everything. Okay, so how are we going to use scorched earth in this side? We're going to use it for denial of service on the enterprise network. So if I were to ask you, what does denial of service mean? What is a DOS? If I were to say, what is a DOS, what is a denial of service? What would you say? What is a denial of service? Yes. Okay, yeah, so we'll just read the slide. So if we read this, it says, normally we're going to send too much information that the server can handle, and many times it causes the server to crash, right? That's what we understand a denial of service to be. Except, as the attacker, as the programmer, I feel that definition is insufficient to say exactly what a DOS means. Because in my opinion, the definition of sending so much information in order to let the server crash is more of an affected. It's more of, I guess, the measure of effectiveness if the DOS is working. So can I access the server? No, it has crashed. The DOS is working. Instead, let us refer to the Book of Solomon, for a new definition for DOS. Instead of thinking of a DOS as sending so much information, let's only consider it to be resource starvation. If I can starve the available resources on a server or an enterprise or a system, then I can actually have a measured effect such that access to the system at a minimum is degraded and at a maximum is disrupted. Okay, I think that's better. So now I can ask another question as the attacker, as we're developing these exploits, how do I starve resources on a server? Well, there are actually many techniques. Many techniques exist. And one I developed 2 weeks ago, another one I developed on the airplane, which was like a 9-hour flight or so from Washington here. I was like, wow, let's see if this works. Kind of heartache, because sometimes when you're just in the zone programming, you're kind of angry at the world. But we have, I think, 4 things that I learned from that process. And the first, if we want to do a DOS, the first is to analyze the legitimate traffic. So if I want to DOS a website, let me go to the website and look at it with a packet analyzer, i.e. Wireshark, to see what does it look like if I want to DOS the system. Okay, the next thing is to learn the protocol and the structure. This is very important because a DOS on a website, an HTTP website, is going to be completely different than the way you try and DOS an FTP server. And I learned this the hard way. I was like, okay, I just programmed the website DOS. Let's go ahead and do the same process for an FTP server. And it was like, punt, slap in the face. I'm sorry. I need to refer to this RFC 959 to understand how to first authenticate with that FTP server and then to send it commands to starve its available resources and then cause a DOS. Okay, so I think, all right, good. That's our clue for a DOS. So let's do this real quick. Let's do this. Okay, so I am also hosting our Hack in Paris website on a separate IP address. This is at 192.168.229.9. And everything is identical to the main website that we're familiar with. The only thing I added was this script at the top, so that if I refresh the page, then you can see that the script is updating appropriately. That means whenever I went over to the website and said, can I have your index page, it sent me the index page along with the script, my browser executes the script, and now you can see that, okay, I just received information from the server. Okay, let us now have a visual of what that DOS looks like on the actual network. Have we heard of Ether 8 before? Ether 8, raise your hand. No? No? Okay, only one. Wow. Ether 8 is incredible. It's incredible. So what do I do with Ether 8? Ether 8 can allow me to see various nodes in my computer network, and also it kind of does a visual, whichever node receives traffic, I can kind of see it expand and go big and go small based off of its bandwidth utilization inside the network. So right now, if I were to move this over, and this is working okay, Yeah, good. So you actually see that this is my system that sent the request over, and then this is the server. No, this is my system, and this is the server. He sent an initial request over to the server. The server sent a lot of traffic back to the system, and then it goes away, because right now we're not exchanging any information. So let us use intuition. If we are going to execute a DOS on that network, what do we expect to suddenly appear on EtherApe's side if there are a lot of traffic is being sent at once? We'll pretty much expect this to go completely red, because red is the protocol for HTTP. Okay, so let's have a visual. What does that DOS look like? Let's see. Okay, so if you want to execute a website DOS, please again use this for good and not for evil. How is anyone going to use website DOS for good? I don't know, but you figure it out. Okay. Okay, so if I come over here, I enter the shortcut DDoS website. Okay, then I enter in the IP address of the website. You should be able to do URLs. I think I mainly programmed it for IP address. It works best that way. And then 192.168.228.139, right? And you can leave the port off if it's 80, but I'll just enter it in. So once I hit enter, I'll just use one. I'll just let one implant execute the DOS. I'll let this guy. So if I hit OK, oh, good, there it goes. OK, so what you're seeing is this, oh, the website is dead. What you're seeing is this implant just sent so much information to that web server saying, can I have your index page? Give me your index page. Not only that, I instantiate about 10,000 threads, each person saying, give me your index page right now. So if that is successful, the website might actually have too much information that it can handle, and then it's going to crash. Okay, so let's see if it crashed. Okay, it crashed. So if I were to refresh, you saw before that refreshing is gone. So you saw before that refreshing the web page showed the JavaScript that we wanted to, or I can see the time. Now if I'm DOSing that site, it's down. That server actually crashed until we go back and restart the server. But even if we did restart the server, you would see that, how much time do I have? Do I have 2-3 minutes? Okay, good. Okay, so let's try this. Let's see if we can make this look right. Okay, it's not going to appear as I wanted to, but let's just say right now you see that the agents are kind of sleeping, waiting for that server to come back online. So if I go back this is the machine that's hosting the server, also what I use for the demo. I use Abyss Web Server to host that website. Let me go ahead and close it down because he's finished, he's done for. Okay, so if I just restart it, okay, if I restart that server and then go back to, yeah, so you see the implants recognize, server's up, kill it. So it's going to try and kill it again. And now the server, we try to bring it up, but it happens so fast. If I try and reload, the server is done for again. It's still down, so they just wait and wait and wait until you say, okay, go ahead and stop the DOS. I think they've suffered enough. So if I want to stop the DOS, if you go over here and say halt website DOS, okay, then yeah. So now the agents, the implant stopped and they will stop the DOS. Okay, so at least I give you a halt feature. The next one is FTP. That one okay. I think you can tell I like that one. I did that one on the plane. Okay, so if I want to go to our FTP website, I'm also hosting the FTP website on 192.168.223.139. Okay, so if I can, and I don't know if you caught that, you can see that I have a socket established from .1 to 139, because that's what I'm connecting to. And let me log in anonymous. Did I spell that right? I didn't? Okay. Let me try that again. Anonymous. Okay. Okay, good. Logged in. So if I enter binary mode, you don't have to do that, but wow. Okay. So if you can see that I can interact with the FTP server appropriately, right? So if I were to close the socket, close the connection, and just log in again, I can still log in. Let me use the -A. So good. So I'm logged in as anonymous. So everything is working appropriately until we DOS it. Okay. So this is what we added. We added the FTP DOS. Let me make this larger because there are additional parameters to enter in. Some things you can just leave default. So right here, the first thing we'll enter is the IP address to the web server that we're going to DOS, which is that right there. And then the next is the default port number for the controller, and then the default port number for the control, and then the default port number for data. That's just your normal FTP protocols on port 21 and port 20. Okay, and then the username that I want to use to try and log in, we will use anonymous for now. I'm going to add more to this feature. It's just new. that I think this is the most I could add in. And then just a blank password. Make sure you leave the quotes intact so we know what to parse for the password. And then I haven't added more to this yet, but eventually you'll be able to daisy chain additional commands that you want that FTP server to execute whenever we're trying to log in and DOS that system. But for right now, it works for one command each, and I will just say list. So this means if this is working, log in, authenticate with the server, and then list whatever we have. But something I did with this DOS is that it gets angry. Okay, good. So as you can see, our DOS, it starts to grow bigger and bigger and bigger and bigger and bigger. So that eventually what's happening, I'm spawning as many connections as possible. After I try and spawn many connections, I then try and spawn as many more. So this will go up to about 20,000 connections as possible as it can until eventually the FTP server will crash. Now, at this spot over here, I put a status. This is currently how many open sockets I have to the FTP server. Okay, so you see, it's just going to continue to grow and grow and grow. And then every 100, I give you a status on this side. There it is. Okay, so right now we have 300 open sockets, and it's going to continue to grow. So, sorry, I'm going really fast. I want to show this. Let's see. If I were to show the FTP FileZilla, it's probably not even going to show for us because it actually freezes. In fact, the whole computer is freezing because it's just receiving too much information. Open, quickly. 400. Okay, so right now we're at 400 sockets. Okay, so finally, you can barely see this, but I cannot interact with this. So it says not responding because our DOS is being effective. Oh, finally, look what happened. Okay, I was waiting for this. Okay, so let me come back to this side real quick. I like to give you status to know whenever our DOS actually detects something. So we told you that the agents are sniffing the network to see, okay, anytime that we have a website DOS, if my agents detect that the website DOS is effective, it reports back to you saying, okay, I think our DOS is good. Go ahead and check it out. And hopefully the website is no longer active, DOS complete. In this case, we have the FTP orbiter, it's our DOS bot saying, okay, we actually just received a status code 421. And if we refer to the RFC 959, status code 421 means the connection has been refused. And not only that, the bots report what the server actually says. The survey says that too many users are logged in for this account to try again later. I don't like the looks of that. So let me go back to, let me just start a new one. Okay, if I were to try and do an FTP connection, again, 223.168.223.139 FTP. Yeah, so I want to log in as anonymous. Okay, I say enter password, it refused my connection because it is saying that too many users are logged in for this account, so we're going to try again later. So was this DOS effective? Yes or no? Yes, it's effective? Okay, let's see. So if we were to look at the network again, they're still having at it. So they're trying to DOS it as much as possible. So eventually, let me come over here, and this will be the last one, then I'll finish because of time. If you say halt FTP server DOS, okay, the agents report back the DOS, we're halting the DOS, and now you can see no more traffic is being sent as much as possible, so that FTP server should be working okay. So if I were to try one more time to log in, is this what we used before? So the FTP server as anonymous, password, bam, there we go. So we can log in again. So at least that's just a few options that we added in to our botnet to allow you to do as many things as possible. Let's go back here. And then we'll just finish. Okay, so we just finished demo. We did the DOS. So additional features. These are additional features I did not talk about, but are built into the Splinter botnet that I have. And then I also released tutorials on if you wanted to do this yourself, how would you be able to do it? Because my goal is for everyone to be able to create their own botnet and exploit that computer network for good, not for evil. Okay, so here are things that we did not talk about: orbiter payload, clipboard injection, UAC spoof. If we had more time, I would have shown a few. I don't see Leyland. Where is she? Oh, okay, looks like I'm out of time. Okay, all right, next slide. Okay, if you had any questions, you can, this is where you can actually grab the code, because I released the code, and also the implants that we have. I have new updates coming, like the FTP that we saw. I just programmed that on the airplane, so as soon as I get back home, on Sunday night, you'll see the new version that will be uploaded back to GitHub. And if you have questions or email, just send me an email. I'm pretty much always online. Well, I'm always online 6 hours behind, I guess, or however many in the US. Okay, and then also, if you have any questions, you can also send me a question on GitHub. Yes, questions? Oh. Wait.
I just have one quick question. It's just a detail. In one of the slides, you were showing the credential stealing attack, and you said you edit the host files, and then you send the user to the wrong server, and then you just do a redirect to the actual server. But how you do that if it's in the host file? Like, do you use a proxy, or how do you do that?
Oh,
because
actually,
that's a
no.
problem.
Okay, so your question was, how does the redirect really work if I just added one entry to the host file?
Yeah, but what do you do when you want to redirect to the actual website? Because you can't, because it's in the host file. It's always going to go to the very IP, and to change the host file, you have to restart the browser to actually make it work, because it caches this. So how do you solve this problem?
Okay, so you're saying if I want to remove the entry that we added?
Yes.
Oh, well, okay, I don't have time, but if you saw, when I did grab host file, we actually grabbed the original host file from the infected machine. So the next thing that you do is poison host file again, in which you can actually download or re-upload that original host file back to the computer machine. So now the host file goes back to how it was originally. So you, in essence, remove.
But the browser is caching the information, so you have to restart the browser first.
Right, and that, honestly, that's okay to me. If the user has to restart their browser, we do that all the time.
Fair enough.
So, yeah, so that's, thanks, good question. Any other questions? Oh, yes. I hope it's not about sunspots or, where's the wind?
I'm not that basic, okay? I was just wondering if you're going to have a solar flare out on to Splinter anytime soon.
Oh, okay, yeah. So the question was, are we going to have a solar flare added? Yeah, how about version infinity +1? Okay, then you'll see solar flares. Okay, anything else? Anything else? All right, honestly, thank you so much for your time. If you have questions, please see me. Thank you.